All right, everybody, this is lab number 2 associated with communications, ETE335. This laboratory focuses on signal values. There's many ways to measure a signal value. Peak to peak is one way, average value is another way, RMS is a third value. All of three measurements have their place, but there are different mathematical calculations associated with each one. We'll start with the simplest, V peak to peak, then move to V average, and then move to RMS. RMS is particularly important to us because it's all about the power measurement. Okay, let's take a look at the lab setup. The lab setup, as you'll see, is extremely simple. We have the generator, the arbitrary waveform generator, and the scope, and one cable between them. That's it. What we want to focus on is the actual measurements of three quantities. V peak to peak is already shown on the screen. We are going to add the average value calculation. And lastly, we want to add the RMS calculation. Those three values, peak to peak, average, and RMS, are what we are going to examine in this lab. But we will be changing things like the shape of the wave, triangle, square wave. We will also be adjusting the offset on the arbitrary waveform generator. And as we adjust the offset, we can adjust the level of the waveform. The second part of the laboratory we're going to focus on is on the arbitrary waveform generator itself. Here's the icon you will run. Little splash screen there. And this utility allows you to actually create and send waves to the arbitrary waveform generator. If we want to send a sine wave, we simply select sine wave. Then we select expand to fit under the math menu. And we see the sine wave expanded across the memory. And then we click to send the signal to the scope. There's a little splash screen to tell you some information. You want to set this up at 2.2 volts. And we will send it. And we'll go and look at the scope now. And the signal is there. Now, what we'd like to be able to do is actually create. One of the great things about an arbitrary waveform generator is the ability to create new types of signals. The one we are going to create is actually a full wave rectified signal. Now, a full wave rectified signal is like the absolute value of a sine wave. So first we'll create a sine wave. Then under the mat we'll expand it to fit. We'll select the segment. Screen goes white showing which was selected. And then under math we can select absolute. And we see the full wave rectified signal. Then we can send this signal down to the arbitrary waveform generator. And then we see our signal. Now, cooler than that, we can also create something like a half wave rectified signal. How do we get a half wave rectified signal from the full wave? Well, if we simply add a regular sine wave, which is going positive and negative, to this waveform, that will do it. So go up to the math function, addition, and we will simply add a sine wave, which is selected directly. It is, make it the same amplitude, 2 volts peak. Then we will add those together and you'll see the result is a half-wave rectified signal. Send that down to the oscilloscope, and away you go. Half-wave rectified signal. All right, again, the three values we're going to focus on: peak to peak, average, RMS. That's it for the laboratory.